I asked my in-class students to do 8, 9, and 10 for homework, so I need to make a key for them to go over at the beginning of class, so I might as well make a video of me doing these so my e-learners can see it too. Number 9 says the arrow is fired into a small target at rest, so the arrow and the target are separate from each other to begin with. The arrow's mass is 0.02 kilograms, and the target's mass, kilograms. I chose M1 is the arrow because it came first in the equation for no other reason. 1, 1, 2, 2. And then they are together after the collision. So the arrow becomes embedded in the target, and they are moving together as one after the collision. So I have no initial velocity of the target, so I can cancel that part out of my equation, leaving me with the arrow's mass and velocity is equal to the sum of the arrow and the target times the velocity that they are moving together after the collision. So my mass is increasing, so my velocity should be going down because of conservation of momentum. And what else are we given in the word problem? If the speed of the arrow and the target combined, this is my post-collision speed of 0.67. This is my velocity after the collision. What is the initial speed of my arrow? Initial, right? So this side is initial, this side is final. So because I'm almost rearranged, I will just move my M1 to the other side. So I'm fully rearranged. So the velocity of the arrow is going to be equal to the sum of the masses times the final velocity, and we're going to divide that whole thing by M1. Plugging it in, V1 is going to be equal to 0.02 plus 2.5 times 0.67, all divided by 0.02. Because my velocity, my mass of the arrow is significantly less than the target, I'm expecting a significantly greater initial velocity. I expect it to be greater than that. Let me see what I did here. Plus 2.5 times 0.67 divided by 0.02. There we go. I must have put something incorrect in my calculator. All right. So there we have it. Our initial velocity is going to be 84 meters per second. And this is for number 9. Number 10. Two cars rear-end collision. We have M1 is our Honda, moving at 20 meters per second before the collision. Our M2 is the Ford, and it's moving at 15 meters per second. Their bumpers become locked and they continue to move as one mass. What is the final velocity? So they're separate before they collide, and then they're going to be together after they collide. So I have 1200. If I want to rearrange this, I would just divide both sides by M1 plus M2. I'm going to plug in the numbers because I want to make sure my order of operations is correct. So I'll multiply my momentum of the Honda plus the momentum of my Ford is going to be equal to the sum of my masses, which is going to be 2200, and they're moving together with a final velocity. So let's look. I think it's going to be somewhere in between 20 and 15. Right, this one will slow down. This one will probably speed up. Divided by 2200. Yes, my velocity will be 17.7 meters per second. All right. So I found my momentums, added them up, and then divided by the 2200. For 11, we have a dog with M1. And a canoe M2. They are together before the dog jumps out of the canoe. So that must mean that they are moving as one before he jumps out. And then they will be moving separately after he jumps out. So we can assume that the initial velocity is going to be 0 meters per second and cancel this part out of our equation. So it'll end up being 0 is equal to the other side of our equation. The dog's velocity, so we identified the dog as M1, so we'll identify the velocity 1 that goes with the dog. What is the velocity of the canoe? So if they're at rest, one of them must be moving forward and the other one must be moving backwards in order to have momentum conserved. I solved it showing you a different way in the first video. I'm going to solve it like this, not rearranging the equations for this video. So the dog's mass, the dog's velocity, the canoe's mass, and we're looking for the canoe's velocity. When I do this math, I get 18 plus 40v is equal to 0. I'm going to subtract 18 on both sides, giving me negative 18 is equal to 40v. Divide both sides by 40, giving me a velocity of negative 0.45 meters per second. All right, the dog is moving forward, the canoe will be moving back.